This video is an introduction to harmonic intervals and tuning. When we're creating music and organizing sound, we normally have to pay a lot of attention to how we organize pitch. And the pitch of a note is largely related to its frequency. So the higher the frequency, the higher we perceive the pitch of the note to be. Pitch is actually a continuum. Although the frequencies go from very low to very high, and they can glide, we rarely do that. What we normally do is divide this continuum into discrete pitches. From these we can make things like scales and chords. We're often concerned with the pitch difference between two notes, and we call this an interval. So when we talk about tuning, what we're talking about is how we determine the correct size for each of the intervals. And as we know, intervals have various names such as the tone or the semitone, or we could call them minor seconds, major thirds, perfect fourths, etc. As the frequency of one note moves away from another, the pitch does not just sound like it's getting further and further away indefinitely. Actually, what happens when the two pitches reach an octave apart, part of our perception says that the tone has returned to its starting place. We can recognize the 2-to-1 frequency ratio as being something which makes them sound kind of the same. Now, as we continue through the next octave, the tones sound very similar to the octave lower than that. And it's so similar that we actually give them the same note names. Often we don't actually care which octave a note is in, we just want to know which note it is. For example, if you want to have a C chord, we just need to have the notes C, E, and G. And regardless of which octave they're in, it will still be a C chord. So we can say that pitch has two distinct aspects. One is the chroma, which is it a C, or is it a D, or is it an E? And the other is the tone height, which octave is the note in. Now go and try the octave catcher application and you can see how well you can hear octaves.